My name is Martin Wrigley. I'm the Project Specification Manager for the North for ROCKWOOL. We're going to look at fire safety for buildings above 18 metres, obviously very relevant, on vogue given what's happened on the 14th of June of this year. Usually what I'd ask is we take questions while I'm presenting. If we could leave it till the end, just want to keep the flow going. Obviously we're all, you can see we're all attentive, which is good, so hopefully we'll stay that way. So this CPD looks at rain screen cladding systems, a combination of the various designs and products that are out there on the marketplace. We'll also have a look at rain screen cladding systems and how you can obviously not compromise on the design, in particular for buildings above 18 metres. And we talk about 18 metres. What I'm seeing, certainly since Grenfell, is an interest in cladding systems and using non-combustible insulation from everything below 18 metres as well. A belt and braces approach, but again, we'll touch on that shortly. So, the contents, we'll have a look at ROCKWOOL. I'm sure a majority have heard of ROCKWOOL before, celebrating 80 years this year. We'll have a look at background as well, BR135, obviously that's the driver in respect of external insulants. And also the testing, BS8414, which is full-scale fire testing, both parts 1 and parts 2. Then take a brief look at all the stakeholders. So all the stakeholders I'm talking about, Aviva, Zurich, Allianz, they're getting pretty vocal, as you could probably well imagine. They're looking at mitigating a lot of their loss, which currently stands at just over £9 million a day as of 2015. And then compliance without compromise. We'll look at the insurance that are out there on in the market. Everything from your foams, glass and stone wool. So the ROCKWOOL Group, as I said, we're celebrating 80 years, still family owned to this day, owned by the Carla family. Headquarters is over in Denmark. Operational in 37 countries worldwide, and you can probably see there from the chart, majority of it Western Europe, 49%, Eastern Europe. We're commissioning another plant over in North America. We've got a sister company, Rockpanel and help me out, what's the other one called? Rockpanel and Rockfon. Oh, how could we forget Rockfon, of course. Rockfon manufacture ceilings, Rockpanel external cladding. We'll talk about Rockpanel shortly when Jenny takes the stage. Net sales in 2015 were 2.2 billion euros, and we've got approximately 10,500 employees worldwide. Here in the UK, we produce out of Pencoed in Bridgend in South Wales, and I should hopefully, somewhere, let's just have a look, I have got a sample. It's basaltic rock. So we actually bring that in from just outside the Giant's Causeway. You'll be surprised at how many specifiers, architects out there still think we're made out of Newcastle brown ale bottles. No, that's glass insulation. This is ROCKWOOL. So we bring it in from just outside the Giant's Causeway. We put it on a boat in Belfast, ship it down to Cardiff, from Cardiff up the M4 to Pencoed in Bridgend. Been operational in there since 1979, just over 450 employees here in the UK. We've also got a marketing and sales function operating out of Chiswick in central London. And the plant was expanded in 2009. We've got probably what could be classed as the most up-to-date production line within the ROCKWOOL Group. We have the patent in respect of dual density technology, and what I mean by that is on the interface of the rain screen duo in particular, which you will find in the external facades. It's a less dense than the actual main core of the broad body of the insulation. The benefits of that, it allows to accommodate any undulation, in particular on masonry substrate. So you're going to be reducing that cold bridge effect. So background, anyone would like to tell me why 18 metres? Why not 12? Why not 13 metres? Come on, looking for a bit of participation now. Anybody?
Tied up with the old building regs, 50 feet, 60 feet.
Yeah. Alvin. Yeah. Well, it's actually, yeah, you're right. It's also deemed it's deemed the safest height to tackle a fire from street level to parapet. But I'll give you a fact. The first responders to Grenfell on the 14th of June of this year, the tallest ladder they had on the appliance, the first appliance to reach the scene, had a reach of 13.6 metres. Yes, 13.6 metres. What they typically tend to do, though, is stack the ladder on top of the appliance. Unfortunately, they couldn't do that at Grenfell. Reason for that is because of all that aluminium, all that insulation was melting, dropping down. There was no safe way of actually getting on the underside of Grenfell and tackling that fire. Even so, the fire spread was that rapid, it would have been fruitless. So as you can imagine, there's some special requirements in respect to buildings 18 metres or above. You can see here on this picture, that's the Kingdom Tower, Jeddah, Saudi Arabia. That's going to be coming online in 2019. It's 1,000 metres tall or 167 stories. Tallest building, just to put it into context, in Manchester is going to be Owen Street. That's going to be 67 stories tall. It's going to tower, pardon the pun, above Beetham Tower or the Hilton Hotel. So 67 stories is going to be the tallest tower in Manchester. Renica Build are the main contractor of that project. Pales into significance, 167 stories. The other thing you've got to remember as well is the proximity of other buildings, because you've got that 1 metre notional boundary, which Jenny will touch on shortly. Because of course the heat given off, especially on some of these ACM fires that we've seen over in Dubai, downtown, is quite intense. So you're going to start secondary seat fires, of course. Access for firefighters. Also, one of the other things that we find difficult when drawing up engineering judgments is open planned offices. I know there's a couple of people here who've worked on St. Peter's Square. Open plan, you know, it's very difficult. You've got a lot of products in modern day offices which are flammable, which are combustible, which will contribute to that fire load. So it's very difficult in trying to contain a fire when it's open plan in that nature. I'm going to click on this link, hopefully it'll work. It'll give you an insight into some of the innovative ideas, in particular this one in Dubai. Yeah, there we go. Oh, where's it gone? Hopefully it'll come back up. Yeah, 1 minute, let me. So you can see from that, yeah, they have actually ordered 20 jetpacks for firefighters and first responders. That's not so the firefighter straps himself into this machine that you see here and tackles the fire. That's so they can go up with a camera and identify the heat signatures within the building and then direct the first responders on the ground to where those heat signatures are within the building. As a safe flying height of 3,000 metres, and I kid you not, I had to read it twice, but this thing is actually powered by kerosene, and kerosene is what drives your aircraft. So you get close to the fire and I'm sure you're going to get involved with it somehow. So, I do apologise teaching you suck eggs, but the fire triangle, yeah, we're back to basics, I'm afraid. Fuel. Obviously, you need fuel that can be taken in the form of paper, of wood, carpet. Most materials will contribute to the fire load in respect of the fuel. You've then got the heat. Obviously, that's going to be the catalyst. Heat's required to obviously ignite the fire. And then oxygen. You only need 16% oxygen for a fire to take hold and ignite. 21% is the ambient oxygen level, within a room. If you eliminate one of those sources, then you're going to extinguish the fire. Pretty simple, really, isn't it? So take out one of those elements, and then you will extinguish the fire. I'm going to show you a short video in respect to the candle test, filmed over in Sweden. Gives you a bit of an insight as to how quick a fire takes hold. But you can see from this slide here, from ignition point, start of fire and flame spread, it's usually pretty rapid. We then get to the point known as flashover, so we're going from, as you see from the video, from 200 Celsius to 800 Celsius. Anything above 600 classed as flashover, so everything within the room is then literally consumed by the fire. So I'm going to click on this video link and hopefully it will work. So what we're looking at is here, the timer here and the temperature. As you'd expect, you can see various products in this video which you would find in any modern day office. So you can gradually see the temperature rising here. Just keep an eye on that. We're now reaching flashover, so 800 degrees Celsius, all that toxic smoke. Approximately 60 to 66% of people will die in a fire through toxic smoke inhalation. So the smoke toxicity, as I said, you can see the figures from there, 2013 to 2014. 41% of fire-related deaths were through smoke inhalation. And you can see on the list there, asphyxiant gases, carbon monoxide, hydrogen cyanide. So I'm sure once Dame Hackett reports back, there'll be, and Sir Martin in their report in respect of the 14th of June Grenfell, there's already talk about a lot of people perished in that fire due to the inhalation of hydrogen cyanide. Irritant gases, hydrogen chloride, bromide, fluoride and oxide. So those irritants, although they're not going to kill you, they will obviously irritate the esophagus, the lining, the throat lining, etc. So if you have a look at the external fire spread in high-rise developments, there have been a number of tests undertaken, and one of them obviously post-Grenfell. One test in particular which has demonstrated that you need, or you only need, a residual cavity of 25 millimetres to create that chimney effect, that spread of fire within the residual cavity. So as you can imagine, a lot of fires will start or there's an increased risk during the construction period. In particular, timber frame. We've seen a number of high-profile timber frame fires in and around the northwest over the years during the construction phase. But high-profile fires within high-rise buildings obviously increasing the need to enforce good workmanship and obviously ensure that guidance is followed. Now, building regulations all make reference to the safe design of high-rise buildings. As you think back onto June the 14th, it was a warm, very warm evening, so the windows are open, curtains are flapping. Obviously they're going to contribute to the spread of fire to the external surface that we saw within Grenfell. So BR135, first edition came about in 1988. It's actually just 6 months after BS476 Part 7, which is Class O. We call it Class O, it's actually Class 0, but we'll keep referring it to as Class O, as the majority of people know it as. So at this time, there was no full-scale fire testing. Basically what you did, you turned up to a lab with your sample, tested it, and that was it, off you went. They'll tell you how quick it burnt. They'll give you an idea on some of the droplets coming off. They never measured the amount of smoke, didn't even look at whether the smoke coming off that product tested was toxic. But nonetheless, that's all we had back then. And over the years, we have seen some step change. I think there's a majority of you in this room old enough to remember the fire in Woolworths in the mid-70s. We saw a slight step change there in respect of Part B. We were promised change to Part B and the building regs in general after Lacanal in 2009. Probably safe to say, given what's happened on the 14th of June this year, we will no doubt see a huge overhaul. Hence the reason, obviously, why you've got Sir Martin and Dame Hackett being appointed to look into the fire and also the building regulations as they stand today. But nonetheless, full-scale fire testing was to come along, and that was really in response to some of the high rise fires that we saw. One in 1991, Knowsley Heights in Liverpool. Then the other one, which was fatal, which was Garnet Court, Irvine in Scotland in 1999. So in 2003, we saw the second edition of BR 135, and this was accompanied by full-scale fire testing, BS 841 Part 1. Now, Part 1 relates to masonry substrate. Part 2 is SFS, steel frame. I'm going to show you a short video in the next slide, and it just demonstrates the BS 8414 test. Basically, it's a 60-minute test. Oh, sorry, 60-minute fire load. You've got the timber crib, which is ignited. That's left to burn. So what we're trying to do is emulate a real-life situation where the timber crib is ignited, everything there, it left above to burn for an extra 30 minutes. What we're looking at is how quick the fire spreads up the surface of that insulant, the amount of smoke given off, the amount of droplets given off, and of course the amount of heat that's going to be generated from this full-scale fire test. I'll just click on a couple of these links. Knowsley Heights. So Knowsley Heights was a deliberate fire over in Liverpool. That was in 1991. You had a waste bin pushed on the underside of the building, and you can see the outcome there. Now, just to think back then, we actually used to clad a lot of buildings in extruded polystyrene. Don't think there's anyone sat in this room who would ever consider that today, but nonetheless, that's the insulant that was used in many respects. And it was this insulant that was main cause of the fire spread and the damaged sea. As I said, nobody lost a life in that particular fire, but the rapid fire spread was enormous. And as I said, it was really down to the fact that lack of fire barriers back then, as you can imagine, in 1991, and also the gases, the combustible gases given off within the facade of that of the insulant. We then had Garnet Court. Now, Garnet Court, sadly, there was a fatality. An old age pensioner lost their lives. That happened just after midday on the 11th of June 1999. And again, the contributing factor to the severity of the fire spread was down to the recent refurbishment of this block. This was an accident. This wasn't an act of arson. But nonetheless, it was a driver in respect of moving forward to full-scale fire testing. So I'm going to show you this window of risk. Any of you will probably have seen after Grenfell, the BBC managed to get their hands on this video, just to demonstrate what an 8414 test is all about. What you see there to the far left, that's stone wool. We've then got foam, and we've then got polystyrene, including fire breaks. There's no clock on here. I'd be interested just to see as to how quick you think it takes to reach the end result. So I'll just click on this. Just have a look at this. So as I said, the polystyrene there does include fire breaks in this BS 8414 test. So what you can just see here is the thermal couplers that's measuring the heat given off from these 10-metre rigs. Also note the smoke as well coming off the polystyrene in particular. So from ignition of the crib, how long do you think it's took to reach that stage? Anybody? Come on, don't be shy.
15 minutes.
No. 2.5 minutes. 2.5 minutes to reach the stage that you see there. Again, the toxic smoke will be the main killer. Does that emulate real life? Probably not. There's no external cladding there. There's no VRB to cut off the oxygen. But that is the state in respect to BS 8414. What we're seeing over at BRE, of course, is full system testing. You've heard the term, of course, field application test, or even desktop study. Talk a bit about desktop study shortly in the next few slides. But nonetheless, yeah, you can see how quick the fire spread there in respect to that polystyrene rig. So the BS 8414 test, as I said, part 1, and then came along part 2, steel frame. Majority of what we're seeing now out there being specified is steel frame systems. The test methodology doesn't change. It's still a 60-minute fire load. Timber crib is ignited, and then everything above then is left to burn. So as I said, we're looking at the spread of flame, and more importantly, the smoke and the droplets given off. So in 2013, we had the 3rd edition of BR135, and what this wanted to do, or what they tried to do, is consolidate some of the information that was being put out there, because you had NHBC muscling in onto the Act. BCA, Building Control Alliance, was also coming along with a number of options in respect of testing, and this document was trying to obviously incorporate the BS 8414 Part 2 test, and obviously do away with some of the misconceptions and guidance that were starting to appear out there in the marketplace. So we'll have a look at fire safety compliance. So, regulatory guidance documents, approved document B for England, approved document B for Wales, section 2 the technical handbook for Scotland, and also technical booklet party for Northern Ireland. So they all make reference to the safe design of tall buildings, and it's really on the back of, as I said, the number of high-profile fires that we've introduced large-scale fire testing. It's probably fair to say, given what happened in June of this year, we will no doubt see a big overhaul, in particular of Part B. And after all, it's been demonstrated that fires will progress 4 to 8 times faster today than they did back in the 70s, back in the days of the Woolworths fire. So I'm sure things certainly need to be looked at in the not too distant future. This is where you see a lot of ambiguity, because what we've seen over the years, obviously we've got Part B as a statutory instrument, Building Regulations 2010. Below that sits approved documents, and then what we're seeing, of course, is guidance upon guidance upon guidance. No surprise there then that a lot of architects, a lot of specifiers are sat there scratching their head, wondering which way to turn. BR135 8414 test, you've then got an interpretive guidance on top of that, coming from Building Control Lines Guidance Note 18 and also NHBC. We've then got, on top of that, a bit more guidance from the manufacturer's tested data guidance and also desktop studies and fire engineering reports as well. ROCKWOOL's approach is pretty simple. It's a linear approach. It's either combustible or it's non-combustible. It's pretty simple, really, isn't it? Either burns or it doesn't. So B4, approved document B4, section 12, and this is really referencing what Chris talked about there, about the external envelope of the building. It should not provide a medium for fire spread. But obviously what we're seeing today is the use of a lot of combustible materials out there in the marketplace, not just the facade, but in various different elements of the building. So if we have a look, fast forward, June 2014, Building Control Alliance came along with this document, Building Control Alliance Guidance Note 18. What initially they wanted to do away with was some misconceptions surrounding BS 476, which is Class O, surface spread of flame. So Class O classification. If any of you know how Class O testing works, you've basically got a pilot light, the sample, Part 7, BS476, the sample is then introduced to the pilot light. What we're looking is a spread of flame from the point of the pilot light, which is then extinguished, all the way across the actual product being tested. So you could, in effect, take a stick of trinitrate and wrap it in a Class O foil. You've then got yourself a Class O product. Once you burn through that Class O foil, you're then down to the core, and usually, depending on what the product is, it is combustible. We've then got option 1, so the use of limited combustibility products, or material of limited combustibility. The next slide I'm going to show you references EN 13501, which is a European fire classification. So as you see there, A1, best performing, non-combustible, stone wool, glass wool, foam glass. Tend not to use foam glass in this country, mainly found in Benelux regions. It's pretty expensive. Nonetheless, it behaves very well in fire. It is non-combustible. You've then got A2, which is limited combustibility, or non-combustible over in Scotland. So that would be Identity, iBinder, face stone glass wool. So you could take a ROCKWOOL product, as soon as you put a paper foil, a tissue covering over it, it then becomes an A2 product, because you're then facing it with a what is in effect a combustible product. We're then coming down the chart, and then we've got B. So as explained by Chris earlier, S denotes smoke, D denotes droplets. So S3, worst performing, D2, unlimited droplets. If you look at some of these ACM panels that are out there on the marketplace, the one in particular on the downtown in Dubai, that went up August of this year. Initially, it ignited in December 2015, Christmas time, 2 years ago. Majority of the damage in the last fire, August of this year, was caused to the property down below, and that was really down to the droplets given off during that fire at those ACM panels. Probably had a lot to do with all the Lamborghinis and Ferraris and Veyrons, which were parked below as well, but nonetheless more damage was caused down below than the actual building itself in the fire of August this year. We're then coming down the chart, C, which is again S3D2. That has a classification of 1, medium risk. So we've got some phenolics and we've got some PIRs, polyisocyanurate. PUR is polyurethane. And then we're coming down the list even further. F, as you'd expect, as you saw during that video, which is the extruded polystyrene. You've also got some PIRs sat in amongst that category as well. Least passage of resistance, as you would expect. If you want to comply and make it fireproof, then you use non-combustible. So A1, non-combustible material, or A2, limited combustibility. When we're looking at facades, you would not use glass in an external facade, and the reason for that is because of its density. Maximum glass product density you're going to get is probably something like a cavity wall insulant, around about 40-45 kilograms per cubic metre. That, when exposed to the elements, would start to delaminate, so you would not use a glass wool product within an external facade. So the other option, option 2, so that's as the proposed test or field of application test. What that is, basically, you have to do a full-scale fire test, a BS8414 test. The issue you have, if you deviate from that test slightly, and when I talk about deviation, I'm talking about even as something pedantic as the helping hand bracket. So if you're testing out in the field place using an envelope bracket, but then on site you're going to use a plaster strip bracket, then that test then becomes void. Unfortunately, there was a subcontractor who fell foul of this procedure back in 2014 on a project down the road from here, namely First Street. They tested using a different manufacturer than what was used during the construction period. Building control came along and failed it. We've now got option 3. Option 3, if any of you was watching the Sky News a couple of weeks ago, 8 o'clock, talking about Grenfell, desktop studies. We're actually the only country who offers desktop studies in Europe. you're not obliged to publish the results neither. So you could commission a desktop study, whether or not you'd get to see the results, you'd get to know whether or not it passed or failure. But nonetheless, a desktop study, as the name suggests, you sit there behind the desktop, you're collating all of the different test data undertaken, and then you're going to predict as to whether or not that would be suitable, whether or not the behaviour in fire would be acceptable. Needless to say, I think post-Grenfell we're going to see desktop studies get kicked into the long grass and will certainly disappear. We've then got option 4. So option 4 is the holistic fire engineered approach, very expensive. If you're getting much change from £75,000, you're doing very well. You're probably looking around about 15 weeks to get a return off this, and at least 3 or 4 reams of paper landing on your desk. And you can see there as to the type of individuals who have to undertake these holistic approaches. Not to say it's not been looked at, but I have yet to see a project which has gone down that route where an holistic fire engineered approach has been adopted. That is the current NHBC guidance, and that is post-Grenfell. So option 1, NHBC have said use of material of limited combustibility. So that is the least passage of resistance as NHBC are looking at it. We've then got option 2, which is a full-scale field of application test. So those are the 2 options open to you under the NHBC guidance as it stands. Building Control Alliance still have the 4 options. Probably fair to say it's being looked at. In fact, I know it's being looked at. Whether or not they'll go down this route, it is yet we're yet to see. But nonetheless, the 2 options are available currently as we stand via NHBC. So testing methods: Euroclass versus national class. It's binary. There's no correlation. So as you can see there, combustible, 0, class O, whatever you want to call it. 1 and 2, 3, 4 unclassified, they're all combustible. You've then got non-combustible or limited combustibility under the national class. Under 13501, the European classification, A1 non-combustible, A2 limited combustibility. They are classed as non-combustible. Everything else is combustible. B right down to F, as you would expect, is combustible. And obviously what we've got to look at is a smoke given off as well with these combustible products, because that is a real killer. 60 to 66% of people, as I say, will die in a fire through toxic smoke inhalation. So if you look at the reaction to fire testing EN 13501, this is what we're measuring during the test: the ignitability, the speed of the flame spread on that during the test, the heat emission. As I said, Jenny will talk briefly shortly about the adjacent buildings, etc. And smoke and toxic gas emission. You've also got to look at the changing character of the actual building products, the melting, the dripping, because that's going to obviously propagate fires. That's going to assist in fire spread. And you can see from the chart there, as I said, non-combustible, limited combustibility. So, said before, our approach is pretty simple. It either burns or it doesn't. So determining the fire classifications, that's the declaration of performance. What we always say to architects, specifiers, ask for the product's declaration of performance. You're looking for the harmonised standard reference. More importantly, you're looking for the declared value in respect to 13501. Always ask for that declaration of performance. They should be forthcoming and furnish you with that information. Any building products manufacturer should be forthcoming offering up that information. Ours is readily available, as you can see there. Download it in a PDF format. So we have nothing to hide, of course. It's all there for everyone to see. So defining combustibility. So non-combustible, pretty simple really, is non-combustible. You've probably heard those terms before: fire safe. That does not define the reaction to fire. Fireproof, fire retardant. Oh, my product is flame proof. does not define reaction to fire. Non-combustible, legally defined term within building regulations, and that's only materials achieving the highest standard of reaction to fire can actually be classed as non-combustible. So if you look at the BS 8414 full-scale fire testing, this kind of like emulates the testing that BRE are currently undertaking. And you've probably seen a lot of panels being stripped off these buildings, and we're coming back with 100% failure rates, passes, etc. But that gives you an idea in respect of the testing methodology and the rig equipment in respect of being used. It is option 2 in respect of NHBC, that full-scale fire testing. As I mentioned before, external fire spread, internal fire spread, obviously mentioned before some of the recent testing. Residual cavity of 25 mm to create that chimney effect is all that's required. So you're going to get those gases given off by the aluminium, by various combustible materials burning away, which are going to create those gases within that void, which are then going to ignite and obviously spread the fire. Mechanical performance as well. Some of the things which are being looked at by BRE, helping hand brackets. Aluminium will obviously melt around about 650, 680. So there's various different elements within an external facade which is being looked at. Not just helping hand brackets, you've also got to look at fixing head screws which are retaining the insulation back to the wall. Some of them out there in the marketplace are plastic, it's going to burn away. Some of the other things that are being looked at as well is the intermescent strip, doing accelerated age testing on some of this intermescent strip, just to see as to whether or not it stands up to time, 15, 20 years, is it still going to expand, close off that cavity during a fire. But what we see there is option 2 in respect of NHBC and their guidance. So fire safety compliance, spoke before about some of the insurers and the risk management companies that are out there. There's a couple of jobs in Manchester, one of them where the insurance is Zurich, turned around and said this was post-Grenfell, you need to take that material off the wall. We will not insure the building unless non-combustible material insurance is used, and also paneling as well. And if you can't get insurance on the building, you ain't going to get a mortgage. So they come in, they're starting to get a lot more vociferous. You can see there the first half 2015, £9.2 million. So you can quite clearly see and understand their position, how they're wanting to mitigate a lot of that loss. Failure to disclose accurate information, very much like insuring your car. If you fail to disclose accurate information in respect to building products used during that project build, then it null and voids your insurance. Obviously, the use of modern combustible materials, that's going to add fire load, and obviously that's where they're looking to turn to some, not just manufacturers, but also people like LPCB, the Loss Prevention Council Board. And what I would say to you, go on the LPCB website, have a look at their guidance. They've undertaken a huge amount of testing. Worthwhile downloading the file. It's a huge file. It's about 800 megabytes. So it's definitely worth downloading and having a look. So guidance on insurance requirements, I spoke there about Loss Prevention Council Board. Obviously they're dictating, giving guidance in respect of products that have been tested out there in the marketplace. And the likes of Zurich and Allianz, they're obviously listening to what LPCB have to say. You've then got the NHBC Foundation, Zurich School and Academy, and then you've got HTM 0502, which refers to fire safety in the National Health Service. But it is LPCB, as I said, in the main, where some of these a lot of these insurance companies are looking at in respect of guidance. That's a statement that was issued by Zurich. That was pre-Grenfell. So as a guide, then non-combustible insulation should be used. So rock mineral fibre type, stone wool, or man-made vitreous fibre, or glass wool, in layman's terms. But this just shows you how more vocal and pressing they're becoming in respect of the insulation products that are actually used there out in the marketplace. I'm just going to briefly talk about the RRFSO, the Regulatory Reform Fire Safety Order. It came about in October 2005, passed, made legal in 2006, October of that year. What that basically means is you, as a fire officer, no longer needs to go visit a site, visit a building and issue a fire certificate. So the building owner will appoint a competent person. That competent person isn't going to be thinking like a fire officer. Fire officer is going to enter that building and he's going to think, can my fire officers tackle a fire on these premises if one was to ever break out? It's fair to say building owners putting forward competent people, legally they have to get it right, otherwise they will be serving time at Her Majesty's pleasure if it's found to be wrong. But nonetheless, it's diluted what many fire officers would see as a very important certificate. It's also worth noting as well that once the building has been erected, put into a place and is habitable, fire officer can attend, very much like Ofsted, can pitch up, no invite, doesn't need your invitation at all, can turn up to the building premises, he can inspect that building, he can have a look at the passive fire protection, and if it's deemed unacceptable, he can then issue a certificate or a warning whereby the contractor or the subcontractor, if they're still about, has to then come back and undertake remedial action. There's a comment from Bridget, I'm not even going to try and pronounce the last name, but that's our public affairs manager there within ROCKWOOL. So 1 million more people on the planet every 5 days in major conurbations. So obviously you can imagine fire safety is all important like never before. And given what's happened in June, I'm hoping to see obviously big changes in respect of Part B in particular. So compliance without compromise. So stone wool, you can actually take stone wool to temperatures exceeding 1,000 degrees Celsius. You're not going to get any of these toxic hydrogen cyanide fumes given off from stone wool. It's going to reduce the effects of smoke damage, of course, and also the risk, reducing the risk of to property and asset damage. Gives you an idea in respect of the temperatures. So polyurethane, polystyrene, around about 200 degrees Celsius, you're going to start to see burning or melting in respect to those products. Fiberglass, 600 degrees Celsius, and as I mentioned, stone wool will take temperatures exceeding 1,000 degrees Celsius. And you can see along the bottom there the time in respect of hours and exposure to fires. Acoustic benefits. I'm going to hopefully try and wake you all up now and just demonstrate as to how ROCKWOOL works in respect of its acoustic properties. Not really looked at when it comes to external facades. On saying that though, we've got one project here in Manchester, Circle Square, which was where the old BBC studios were sited, down the road from here. Very expensive student accommodation. There is an acoustic requirement, and there is why they specified ROCKWOOL within the facade. We're using density in respect of killing or reducing the noise effect. As you can imagine, there's products out there in the marketplace which do nothing apart from act as a flanking agent or reverberation agent when you place them within the facade. But I'll quickly demonstrate, give you an idea as to the benefits of ROCKWOOL and the acoustic benefits. So this is going to bang out probably around 120 dB, give you a bit of a crude idea of how it works. So as you can see, it's working pretty well there and from that crude sample. But if you ever get a chance to visit Bridge End, we've got a demonstration lab where we fire a starting pistol into a tube of ROCKWOOL, which demonstrates it very well on how we work. And the thing with ROCKWOOL, it works very good in respect of all frequencies. So low frequencies, high frequencies. What you find with glass fibre in particular works very well at high frequencies, not so good in respect of low frequencies. So when we're looking at some of the jobs which have been specified ROCKWOOL, Cineworld for one, specified ROCKWOOL. Reason for that is one, because of mainly acoustic benefits. More importantly though, it's behaviour within fire. Obviously you want to buy time to get the visitors out safely. Managed to get the pin in this time. Right, dimensional and thermal stability. So some accelerated testing has been undertaken. The way we stop conduction, convection, or the warm air migrating from the from the warm side through to the cold side is basically trapped air. That's how we slow down the conduction, convection process. You've got foams out there on the marketplace. They use trapped gas, again, to slow down that conduction, convection process. But there has been some accelerated testing undertaken on both products. What I would say to you, Google it, have a look. There's many a term out there in respect of what best performing product is in respect of their thermal and dimensional stability. We as a company, obviously, pretty keen in respect of life cycling costs. Building's supposed to last 75 to 80 years. And it's fair to say insulation, ROCKWOOL insulation, which has been stood in buildings for many, many years, is as good then or now as the day when it was first placed into the cavity. It's also not prone to warping or curling over time. You know, you'll see some of these materials which are exposed out there to the elements, which have not behaved very well when it comes to resisting that warping and curling. I spoke before about the dual density technology. As I said, the interface of the ROCKWOOL rain screen duo is less dense than the core body of the actual slab. Benefits there, obviously, it's going to accommodate any undulation. In particular on concrete substrates. So you're not going to get that standoff which you would probably get with a solid board. Thus it's going to eliminate or certainly reduce the cold bridging effect. It's also quite pliable as well, and you can see here on the helping hand brackets, on the bracket sticking out here, you know, you've not got that dog leg effect. So again, you're going to be reducing that cold bridging effect. It's breathable, so it's capillary action, so it will take moisture in, that hygroscopic effect. It will take moisture in, acts as a capillary agent, so it's going to release moisture as well. We've got, and we're the only manufacturer of stone wool rain screen cladding which has a BBA certificate as well, so that's worth having a look at. That is available to download on our website. This is something, as I said before, our corporate social responsibility, and we have actually secured many a job on the very fact that we can take back stone wool, rock wool, back to the factory in Pencoed and recycle it. Where we have a few issues, it's fair to say, is the fire barrier, which is encased in chicken wire. Reason for that, because it's coming out of the coupler furnace, very much like candy floss, the manufacturing process. Spinning discs, thousands and thousands of holes. Problem is with that chicken wire which encases the fire barrier, once it's secured, the curing oven, it then solidifies. It's going to start blocking up these holes, which can cause issues in respect of density and micron diameter. No global warming potential, and no ODP gases neither. As I mentioned before, BBA certification, all important. When you're looking at third-party approvals, LPCB, Loss Prevention Council Board, BBA certification, and as I keep reiterating, ask for that declaration of performance in respect of the building product, looking for the declared value in respect of EN 13501. One of the things ROCKWOOL is pretty proud of is that there, London Underground. You can imagine London Underground don't start throwing out certificates in respect of insurance that can be used down there in the subway for obvious reasons. We have LUL approval, London Underground Network and stations. C certification, that became mandatory in Europe in 2013. And as I mentioned, LPCB ensures product conformity, and it does as it states on the tin. The other thing to look at is BRE wind test data. Again, readily available from our technical department. With ROCKWOOL being of a higher dense than foam products, when it's fixed in situ, it tends to stay there. So you're not going to fix it in situ Friday afternoon, come along Monday and it's in the pub car park next door, which is what you've seen many occasions, surprisingly, with a number of other products out there in the marketplace, which typically, when the wind picks up, will get ripped off the wall. So fire safety compliance. What you see there is an SFS build-up system. We always say put something there within the SFS. Obviously it's going to help with acoustics, it's going to help thermally, and obviously in respect of fire as well. VRBs, as I mentioned before, all important, and I think Chris touched on it, showed a diagram there, how in Grenfell, the VRB was actually fixed back to the insulation. That is shocking workmanship. It needs to be fixed back to the substrate, impaled onto the L bracket that you see there. And then the ROCKWOOL rain screen duo slab as well. One thing to note, and I said if anyone was watching the Sky News a couple of weeks back, it mentioned there about the calorific value of the insulation wrapped around Grenfell. It was equivalent to 30,000 litres of petrol. That was the calorific value of the insulation and the panelling, which was wrapped around Grenfell. And how do we work out calorific value? Well, we basically take a product, we burn it, and we look at how much heat is given off. In a nutshell, that's how we work out calorific value. There's a statement from Zurich. As I said to you, they are getting quite vocal, and I'm sure we're going to see more and more statements coming from Zurich and the like in the not too distant future. They want to mitigate their loss. They want to ensure that buildings are fire safe. Sadly, in this country, it's been a race to the bottom in respect of U values. It's always thermal first. We've always tempted, or in some instances demanded, the clients that we get 0.11 of a U value. Even 0.10 starting to see now, 0.15 I think Middlewood locks. So yeah, it's always thermal first, sadly. You look at all the countries, Germany, whenever an architect or a specifier sits down, it's fire first. That is what is at the forefront of their mind, is how do I prevent this building from igniting? Pretty simple, you use non-combustible insulant. So checklist to compliance, option 1, least passage of resistance, A1 non-combustible or A2 limited combustibility, as per the EN 13501 table. Option 2, go down the proposed route, the field of application test, a full large-scale fire test, BS 8414 Part 1, which is concrete substrate, or BS 8414 Part 2, which is a steel frame substrate. You can have a look at a desktop study. As I said, unfortunately, we're the only country in Europe that does desktop studies. Whether or not you get the results is a matter of choice. Probably fair to say, and hopefully they will become a thing of the past, desktop studies going forward. Option 4, yeah, we'll move on. Additional credentials, third-party approval. Look for the third-party approval. Look for that declaration of performance. All important, that declaration of performance. And also warranty. Is the product warranted? Can you leave it exposed on site 4 weeks, 8 weeks? So hopefully you've seen a bit of an insight. You now know why 18 metres is 18 metres. It's not 4 metres, it's not 12 metres. Got a bit of an understanding there of BR135, up to the 3rd edition now. No doubt 4th edition will be on its way. The Euroclass system and how different insulants perform in respect to 13501. And the all-important risk management, of course, the likes of Zurich, Allianz getting very vocal, and how they're certainly looking at what insulation products are going into external facades post Grenfell. Going to miss that bit out. I'm going to pass you over to Jenny, and after Jenny is finished, I'm sure we'll take questions. Thank you.